So what we were studying, that you have to first clean the surface, or you have to this is cleaning the surface, not the running the surface. It's removing the dirt and the other things. And then you have to remove the organic growth from the surface. You have to cut all the trees and the branch जो कि उसके बिल्कुल पास में होंगे, क्योंकि foundation भी हो सकती है stone masonry, and there could be roots even from the trees, which could lead to the damage in the structure. Then drainage needs to be checked within the structure as well and outside as well, that there is no leakage happening, and it has to be reopened, and all things. If it's an old structure, it has to be reopened and it has to be properly checked and sealed. तो open joints जहाँ जहाँ पर है, they all need to be sealed. उसमें silicone sealants and other things, you can use them. तो open joints में अभी कहा कि कौन कौन से होते हैं. You have joints near the surfaces, then you have near the joints between stone and any other material like wood use किया या कुछ और use किया, तो उसके बीच में then you have balconies and other things which I told you about. तो वो open joints है, तो वहां पर आप silicone sealants use करके उसको seal कर सकते हो those surfaces, preventing it from corrosion. Yes, you can then also provide the surface finishes there, so on the stone work which are open. So, and if there are any cracks there in the surface already, अगर पुराना structure है and you are repairing it now, you are preserving it now, आपको cracks बंद करनी है. उसके बाद you have to seal the cracks. Once you have done that, now you can start with the cause of the cracking. वो determine करनी है और उसको rectify तो करना है. तो it's not just that you have to seal the crack. Crack को तो बंद कर दिया आपने, उसमें आप मोटार डालोगे या कुछ कर दोगे, तो so that will be sealed. लेकिन एक cause of crack है जिसकी वजह से क्रैक हो रही है. फॉर एग्जाम्पल देयर इज वाटर, उसकी वजह से क्रैक हो रही है. देयर इज अ टेंसाइल स्ट्रेंथ लॉस, वो क्रैक कर रहा है. सेटलमेंट हो रही है, उसकी वजह से जमीन खिसक रही है नीचे, तो उसकी वजह से क्रैक हो सकती है. देयर कुड बी थर्मल एक्सपेंशन एंड कंट्रैक्शन हैपनिंग, तो द स्ट्रक्चर कुड बी क्वाइट बिग, तो उसमें थर्मल एक्सपेंशन हो रही है, तो उसकी वजह से क्रैक हो रही है. तो वो कॉज डिटरमिन करना है और उसको भी रेक्टिफाई करना है, कॉज को भी खत्म करने की कोशिश करनी है इन द स्ट्रक्चर. तो मोटार को हम फिर फाइनली, अगर मोटार इसमें है, we have to try to use such mortar which is chemically inert with the structure. So like for example, you had mortars in old structures, you had just lime and surkhi being used mostly. Now if today you are using the cement and the other things along with this, there could be certain chemical portions within that, so it has to be properly inert. So you do not use first of all water which is acidic, then you do not use materials like chemical plasticizers within the mortar for this masonry. तो उससे तो masonry में भी chemical चला जाएगा and it will lead to its chemical reaction, so we do not want that to happen. तो ये मैंने पहले कहा कि क्लीन कैसे करते हैं, रेन वाटर इज द बेस्ट क्लीनर. तो देन आई टॉक्ड अबाउट द पेंट्स, वैक्सेस एंड द ऑयल्स. आई टॉक्ड अबाउट ऑयल में कौन कौन सा आप यूज करोगे, तो लिंसीड ऑयल विच आई टॉक्ड अबाउट, सो यू कैन जस्ट ब्रश इट ऑफ. देन आई टोल्ड अबाउट वैक्सेस. वैक्सेस में आप मोल्टन वैक्स इस्तेमाल कर सकते हो, सो दीज आर द प्रोटेक्टिव कोटिंग्स दैट यू अप्लाई. फिर मैंने उसमें बैरियम हाइड्रोक्साइड्स, फ्लोरिसिलिकेट्स एंड लाइम वाटर का भी जिक्र किया. तो ये इनऑर्गेनिक मटेरियल्स है जो कि आप यूज कर सकते हो एज प्रिजर्वेटिव्स. दीज आर ऑर्गेनिक वंस, द वैक्सेस एंड द ऑयल्स एंड अदर्स, दीज आर द ऑर्गेनिक मटेरियल्स दैट यू आर यूजिंग. तो जो इनऑर्गेनिक मटेरियल्स में और भी आ सकते हैं, लाइक सिलिका would be used, or you have calcium products. So you could just be using sodium and potassium silicates as silica. As silica, you could be using sodium and potassium silicates, or you could be using silicate esters there, silicate esters. their use as preservatives. You could just go for epoxy resins coatings onto the surface, but these are both inorganic as well as organic ones that you can have available. So you can have silicofluorides as well, which are also used. These are all silica based products: sodium and potassium silicate, silicate esters, epoxy resins, silicofluorides, fluorides. These are all products which are silica based. Then you could have potassium based, similarly potassium esters and others. Potassium silicates all known already. Then you have calcium hydroxide can also be used, which is already present in the lime water. It could also be used for coating. Calcium hydroxide lime water की coating आप करोगे सीधे चूना जिसे कहते हैं, तो which is lime. तो lime finishes आप सीधे उसमें चूने की लेयर ऊपर से डाल सकते हो. It also acts as somewhat in the preservation, not that effective, but as its barrier mechanism, it is available there. So you could have other organic polymers, synthetic organic polymers. I'll not go into the details. One is these resin based, then you could have many others as well as the organic polymers that you can use. तो जो जिनका origin organic has from the polymeric reactions, but organic in nature. Now, what is the property of these preservatives जो कि आप use कर रहे हो? They should first of all penetrate easily into the stonework. So, and they should remain there for a long period of time. And finally, while the it penetrates, this preservative should penetrate within the stone masonry, then uh, it should get dried finally at the end. It should be dried, so it should penetrate as well as uh, remain dry later on. It should not remain wet onto the surface. उस पे एक wet layer की coating आ जाए, तो that's not preferred. So mostly because we concentrate on the surface उसकी सही आनी चाहिए, तो उसमें एक hard crust surface पे आना चाहिए, which is preferred. It should prevent moisture. Every preservative should prevent moisture from penetration within the stone, such that it does not deteriorate through the moisture. It should not discolor, which I told you, it should not discolor the surface. So if it discolors, it gives black patches or something like that, or grayish patches, it's not preferred then. So there should be no discoloration happening to the surface. This preservative should get applied throughout. Uniformly. It should be applied throughout uniformly. So the best would be if it's applied through a brush, something like that. It should not be corrosive. उसी corrosion नहीं होना चाहिए. जो आप preservative use कर रहे हो तो उसी से corrosion हो जाए. For if there are certain salts present in it, so then it will lead to corrosion, or it will lead to the acidic reactions further. तो वो harmless भी होना चाहिए for humans. तो आप उस पर टच कर रहे हो सरफेस पे, and then it's harmful for the humans if they swallow it or something like that. It could be allergic for there could be certain chemicals which could be allergic to people, so you do not want to use such chemicals which are allergic to the people. Finally, it has to be economical as well. तो इसका कॉस्ट भी अच्छा खासा ठीक आना चाहिए. So we have actually studied about the stones now. This is the decay, the deterioration, and we finally talked about the preservation of the stones, how it is done, what are the different materials through which that, and what is the mechanism by which the preservation is done. Now, if you have old buildings, अगर आपके पास old building and you want to restore it, repair it, it's made up of stone, तो क्या करोगे? You might need to replace certain stones completely at times. तो वो बिल्कुल टूट गई है, तो वो स्टोन्स तो आपको निकालनी ही निकालनी है, देन यू हैव टू रिप्लेस इट बाय न्यू स्टोन्स, लेकिन आपको कलर उसको वैसे ही देना है जैसे कि वो पुरानी स्टोन है. So because you do not want it to look new, so then it will not look old. You have to maintain its old theme. तो उसके लिए क्या करते हैं? Then you apply certain chemicals which actually are making it look old, and you also apply certain textures to it which make it look old. So there is a proper mechanism for that as well. If you have to repair the old structures, there you might need to replace certain stones which are totally broken. अगर आपको नए के ऊपर पुराना चढ़ाना है, that's easy, but पुराने के ऊपर नया लाना, नए में स्ट्रेंथ ज्यादा होगी और पुराने में स्ट्रेंथ कम होगी. तो आप एक भारी पत्थर ऊपर डाल दोगे onto an old structure, तो उससे क्या होता है? It could lead to the failure of the old structure as well. So you never want a structure which the top and then उसके ऊपर आप बाहर से stone cladding कर सकते हो just for it to look like it's an old structure. So it's not always कि आप पुराने स्ट्रक्चर में पत्थर के ऊपर नया पत्थर डाल दोगे तो उस पे तो वजन बढ़ जाएगा और वो पुराने पत्थर जो उसके नीचे है वो भी टूटना शुरू करेंगे. You don't want that to happen. So this is about the stone masonry preservation. About the tests that we discussed in the stone last time, there were various tests that we discussed. We talked about compressive strength, we talked about tensile strength, we talked about transverse strength tests. There could be even more tests like water absorption, there could be sampling tests, there could be density tests. But I will not go into the details, I'll just name them. It's not in your syllabus that we study it right now in detail. You have water absorption tests, you could have density tests. You have porosity tests, जिससे आपको इसकी porosity, pore content पता चले. Water absorption I detailed. You can have sampling tests. हम sample stone का sample कौन सा select करें, कैसे करें, how much do we take each sample, तो वो sampling tests. There could be now deterioration related tests like you have resistance to infection, to the growth of algae and other organic matter, वो भी study कर सकते हैं. You have sodium sulfate crystallization tests, again which is meant for checking the level of deterioration of the stones, वो किया जाता है. You have wear test done on the, तो इसमें कितनी wearing हुई है, abrasion test is done, इसमें कितनी abrasion हुई है due to these wind particles, sand particles, वो test किए जाते हैं. So these are all durability related to tests. They are detailed by Rylem is an organization. You can go to their website, RILEM, Rylem tests for stones manufactured. Quite interesting. There are so many types of bricks. First of all, it's not only one type of brick that you now encounter. You can have so many different types of bricks all over the world, and their manufacturing processes but are almost similar. You don't have major difference in the manufacturing processes, but all of them are made in the kiln. And I have already discussed this. The temperature of the kiln is 800 to 1000 degrees Celsius के करीब एक kiln का temperature होता है. Now I'll be showing you certain figures first. How many of you live somewhere near the old style brick factory, a brick kiln factory? It was known as Hoffman kiln, known as Hoffman kiln. Now it's a ring shaped brick factory. If you dissect it inside, you will get it somewhat like this. It's somewhat like this. This is a dissection of this. An old brick factory kiln. Now you have different chambers here. If you have a look, there are different chambers at the base, and there is a walking area at the top. Now these chambers are all lined. इनमें lining दोनों तरफ से होती है, and they connect. One chamber connects as a ring. ये ऐसे connect हो जाते हैं to the other. So they are connected as rings, and then there are more connections happening. यहाँ नीचे से there is a burner, और यहाँ से आपको heat आ रही है, and then it goes through the chambers as hot air into different chambers. And then there is one exhaust provided here, probably. No, this is the exhaust and this is the burner. So this is the exhaust and this is burner. So there are exhausts जिनकी वजह से then that is going here then finally, and this is going up into the air through a chimney. It goes up into the air. It's not it's taken to a height. So you should usually have a chimney at a particular height, ताकि pollution the pollutants do not remain suspended at the bottom level during winters. Most of the so it's better to take it straight away to the top through the chimneys. So this was the first resemblance of a brick kiln of an old type, the Hoffman type. But Hoffman type bricks kilns are still being used in different places of the world. For example, you have this one. This is made in stone. The diametric representation of this Hoffman kiln is somewhat like this. So you can see that now this is the modern version of the Hoffman kiln. You have different chambers here. These are all chambers, the outer chambers, and these are the inner chambers. And then there is a central ring. Now, if you can have all these areas are then filled up with bricks, or in these chambers all throughout, you will be having different places for burners and the air to escape from these chambers. And bricks are placed here between these 1, 2, 3, 4, 5, 6, 7, 8, these. So this is the modern version of the Hoffman kiln that you have as of today. So these are very big plants, the kilns, where you have lakhs of bricks made from one kiln at one particular time. So the main source driving the hot air is the coal. Although in now modern ones, because you want to cut down the pollution, oil is being used, and even now the electrical furnaces are being used in different parts of the world. So now the oil is being used as a gas production. Oil and gas is being used as a production. एक compressor बीच में डाला गया है, and then it's being utilized for heating up the furnace, which is way chamber ऐसे बनाया जा रहा है, closed chambers, उसमें oil and gas is being pumped inside in these chambers. Now these could be also driven by electricity, simply by electricity. It's electrical uh, thermo sensors like these. So you have electrical brick kilns now, but it costs a lot of electricity if you run such electricity type chambers. So you could be having a brick kiln somewhat like this. This is a tunnel type. This is a tunnel type brick kiln in which bricks are pushed into the tunnel. So this is another form of brick making. Electrical ones, they have, these are electrical ones. Run by power supply, the bricks are taken into a tunnel-like thing and it's heated up by electricity, and they the bricks are baked there. But it requires a lot of electricity for. So now if we shift to the solar and this driven